In this video, we will be discussing about pointers and array. So suppose I take a variable int b is equal to 10 and I took a pointer b and in that pointer I stored address of b. Right. So what does it mean? There is a variable b which stores value 10, address of b is 200, and there is a pointer which stores the address of b 200 and it has another address, right? And int star pointers means that this is the pointer which stores the value of data type which is an integer, right? Now suppose I write printf percentage d b, so it will return me 10. If I write percentage d and then pointer p, it will return me 10. Why? Because asterisk pointer will give me the value. This will point towards this address and this differencing operator will give me this value. Now suppose I write percentage p ampersand b, this will give me address, and percentage p simply p will give me the same thing because pointers contains the address of the variable, right? And then suppose I have an array. Right here 6, 2, 1, 5, 3 and address is 100, 104, 108, 112, 116, right? And I have my index as A0, A1, A2, A3, A4, and here at compile time I have declared this array as int a equals 6, 2, 1, 5, 3, and then I have declared the pointer, right? Now a is the array name and my pointer, if I store my pointer as array name, it will return me the complete address, that is the base address of the complete array, right? And then suppose I print percentage p a, right? It will give me, of course, the base address, that is 100. If I print q, that will also give me the base address, that is 100. If I print ampersand a, it will give me 100, that is address of this complete array's address, that will be base address. If I print percentage q, that it will give me 300. Why? Because there is my variable pointer which is q, which stores the address of that variable, that data type which I have declared here. So this will contain, this is the address, this will point towards this, so this will contain the base address of this complete array. So this will give me 300, right? And suppose I have to access this value, right? So I will print a of 2, right? Instead I can also print asterisks of a plus 2. How? And this 2 plus 2 means this does not mean that it will go from 100 to 102. No. Plus 2 means it will increment by one size of data type, right? So size of integer data type is 4. So it will increment by 100, then 104, then 108, and the differencing operator will give me value at that address. So it will give me 1, right? Similarly, asterisk q plus 2 will also give me 1, right? Now, asterisk q plus I can be also written as asterisk I plus a, right? And then if I will print percentage p a plus 1, right, this will give me this address, that will be 104. And suppose I print ampersand a plus 1, then this will give me, right, this will give me, what it will give me, ampersand a means complete array's address, plus 1 means at the address after that array, right? So it will give me 120. So this is the difference. And then suppose I have to write a code for inputting the elements of array and printing the elements of array. So what I will write, the logic will be, first I will declare my array int a I, right, then I will declare my pointer, then I will start for loop from I equal to 0, I less than 5, I plus plus, and here I will write scanf percentage d, I will write here a plus I, right, and then for printing the array I will write for I equal to 0, I less than 5, I plus plus, and then I will print percentage d. Now this time simply the value I have to print, so I will put asterisk a plus I. Asterisk a plus I can be also written as asterisk q plus I, and here I can also write q plus I, right? Now one more thing, asterisk I plus q can be also written as I q, or asterisk I plus p can be also written as I plus a can be also written as I, right? This was what array and pointers. Now we will be discussing about 2D arrays. So I am removing this, and then we will be now discussing about 2D arrays. So in 2D arrays, first we will be discussing about declaration. So syntax of declaration is int a. This is data type. This will be name of array. This subscripts represent number of rows, and this subscripts represent number of columns, right? Now 2D arrays can be also called array of arrays, right? How, we will see. Suppose at compile time I have declared an array int a 2, 3 as 1, 2, 3, and then 4, 5, 6, right? So in this array, total number of values stored will be 2 into 3, 6 values can be stored in this 2D array, and the size occupied will be 6 into 4. This is size of one integer variable, so 24 bytes it will take, right? And suppose logically it can be represented as this. right? This is first row, 1, 2, 3, 4, 5, 6. These are my values. Address is, suppose this has address 100, this has 104, 108, 112, 116, 120. Right, from 100 to 123, 24 bytes is occupied. Right, and for accessing, I will write here simply A of 0, 0. This is 0th row, 1st column. This is 0th row, 1st row. First row, this is 0th column, first column, second column, right? So I will write this as A of 0, 1, A of 0, A of 1, 0, A of 1, 1, A of 1, 2, right? Now, suppose this was my representation of column measure implementation. I mean, just a second. This is okay. First, we will see how I can take input of elements of array, right? So I will simply write a for loop starting from I is equal to 0, I less than 2, I plus plus, I less than 2 1 because of number of rows, and then in that for loop I will start from j equal to 0, j less than 3, j plus plus, and then scanf percentage t, right, ampersand a of I, a of j, right. This is how I will take elements of array. Now what will happen, see clearly. For I equal to 0, j will be 1, 2 and 3. Simply what happened, a of 0, sorry, 0 and then a of 0, 1 and then a of 0, 2 and then a of 1, because after this loop, after control we go outside of this loop, then the value will get updated, and then for I1 and then here 0, here A1, here 1 and then A1, here 2. This will be one by one. I will take my elements of array, right. Now, how to store 2D arrays in memory? So there are two methods. First is row measure implementation, and second is column measure implementation method to store array in my memory. So in row measure implementation, the memory can be represented like this, a long tape, and right. So in row measure implementation, I can visualize my rows as this as 0th row, this as first row, right. This as, now here is a slide wrong. This is 5, 3 and 6. This is my 0th column. This is my first column, and this is my second column. Right. Now, this was row measure implementation visualization. For column measure implementation, I can simply write this as simply 1, 4, 2, 5, 3, 6, and address can be, I can write this as 100, 104, 108, 112, and this is my A of 0 0, this is my A of 0 1, A of 0 2, A of 1 0, A of 1 1, A of 1, right, right. Now, how to access location of any element? Suppose I have to access location of, in row measure implementation, I have to access location of A of 1 1. So what I have to do? I have to cross one row, right? One row. Number of elements will be, suppose I have a matrix of M cross N, right? Number of elements in column, number of elements in row. So I have to cross n elements. So what I will write? Base address plus 1, that is, I have crossed number of rows, so simply I into n, right, plus number of elements I will be crossing in that row, that will be what? That will be also your 1, so plus j whole multiplied by 4, right. This is the right. This is the formula of accessing location in row measure implementation for any element, right? In column measure implementation, suppose I have to access this element, right? A of 1 of 2. So for that I have to cross two columns, right? And then, so after crossing two columns, I have to also cross, for crossing two columns, I have to also cross number of elements in that column, that is also 2. And then in my column, I have to cross one element, so I will add this and then multiply by 4 the size plus base address, right. So the general formula for column measure implementation is base address plus j multiplied by n plus I multiplied by 4. And if my index is starting from 1, not 0, I will simply subtract I minus 1 here and j minus 1 here, and the formula will remain as it is, right. If my index is starting from 1, then I will simply subtract 1 here and here, right. Now, time taken to access this element is constant time, so it will be order of 1, right. Now, suppose, okay, now I will be discussing another thing. Suppose this is my array, right. I declared an array at compile time, int a 3 3, right, 6 2 5 0 1 3 4 9 8, right, 6 2 5 0 1 3 4 9 8, right. Now this can be represented as array of arrays, like this. Each row is an array in itself, right. Suppose my address is this 104, and this is an array itself, a of 0, a of 1, a of 2, right? So it can be written as, represented as every array having base address of each and every array having their own different base addresses, and they have these values in as their elements. Right. Now, after that, suppose I will declare a pointer and I can write this pointer as a of 0, then it will contain the base address as 100, or I can also declare a of 0, comma 0. It will also address of a of 0, 0. So it will contain the base address. Why? Because a of 0, 0 will give me an element, and by writing ampersand it will give me the address of that element. And here a of 0, this is name of the first array. That's why it will give me the base address 100 of the first element of that array, right? So in P, 100 will be stored. Now, if I will print P or A or ampersand a of 0, 0, ampersand A, asterisk A and a of 0, all will give me 100. Why? Because a of 0 is an array itself, so this will give me the, after printing, this will give me the address. Asterisk A means complete array. So when I will ask value for complete array, this will give, this is arrays of arrays, array of arrays, right? So complete array will give me the first array as value, and the first array value will give me base address, right? And then again the complete array address is the base address. This already discussed. This is complete array, so it will return value as base address, right? Now suppose I print a plus 1. This will give me 112. Why? Because base address A will give me the first array, and this plus 1 will give me the base address of second array. That will be base address of a of 1. That's why it will print 112, or a of 1 will also return me 112. Asterisk a of a plus 1 will also return me 112, because a is the array. It will return me the base address of first element. It will return me the first array, right? And this plus 1 will give me again the another array after that, and ampersand a of 10 can clearly give me this one, right? Asterisk a plus 1 plus 2. Now this will give me 120. How? Because this returned me the first array, right? And this plus 1 will return me the base address of second array, right? This will give me the value, sorry, this will give me 112. How? This will return me the first array value, and this plus 1 will give me the base address of second array, right? And this plus whole 2 will give the increment with 2 into size, that is 8, so it will return me 120, right? Now if I will put differentiating operator on whole, this will return me the value at 120, that is 3, right? So value of a of I j can be written as asterisk a plus I plus j, or asterisk a I plus j, right? Now on printing a of 1 plus 1, it will give me, clearly it can give me 116, and ampersand a of 1 is the complete array. This plus 1 will give me 120, right? Sorry, 124, right? This is all for this video. We will discuss now, see in the next video.